Hi, I am Mr. Rogers, and you are watching the video lecture for Electric Current and Magnetic Fields, or 1-3, Chapter 1, Section 3 in our book there. And in today's lecture, what I hope to accomplish is we're going to kind of connect electric current and magnetic fields. The past two lectures have been on magnetism and magnets, and we're going to make a connection here between electricity and magnetism. And we're doing this for a couple of reasons. Moving forward, our next section is going to be on electromagnets, which are magnets that are made by electric current. So today we're going to kind of bridge that gap between magnetism and electricity. So to start our notes off here, we have what is an electric current. Simply put, it is the flow of charge, or electrons, through a material. And what I did here, from a previous year, I smiley face circled and also highlighted kind of the key point of this unit, of this lesson. And it says, an electric current produces a magnetic field. There's kind of that big fact we need to know for today. And one thing I want to mention real quick about that is the idea of electricity. Let me go back to the atom. And so I'm going to make a real simple atom. And we have protons, and we have neutrons in the nucleus. We'll do two, we'll do helium there. 2 protons, 2 electrons, 2 protons, 2 neutrons in the nucleus. And then the outside we have these electrons. And these electrons on the outside are really going to be the key. So far, if you remember from before, talking about magnetism, how magnetism is created, it's when those billions of atoms in domain align the same direction or spinning the same direction. And then from there, if those billions of domains can all line up, that metal becomes magnetized. Well, with electricity, electrons, electricity, electrons are able to flow through different metals. And it's that flow of electrons that helps create our magnetic charge here. So what happens, it's kind of a very basic model here, as you can see, here's a circuit, here's our battery, here's our wire, and here's a compass. So right now it's pointing northwest for the most part, a little more north than west. And what happens if you close that circuit and we turn on the circuit so there's a charge running through the wire, you can see here our compass needle is now pointing a little bit more west-northwest than north-northwest. There's a bit of a difference between this compass and this compass. What it's trying to show you is, with that flow of charge, it's creating a magnetic field, and that is pushing or affecting the compass and how it works. So, what is an electric circuit? We have to answer some questions here too, because we need an electric circuit to create an electromagnet, which will be again the big idea for the next lesson. So an electric circuit is a complete path through which charges can flow. So these electrons can move. They move from atom to atom. They're bumping into each other and pushing through. So electrons are flowing and being pushed through the wire. So what does a circuit need to be complete? We need a source of electrical energy. We saw the battery before. Devices that use the energy, resistors. Anything that uses electricity we call a resistor. So that could be a light bulb, your computer, your television. And they're all connected by a conducting wire and switch. So ability to turn it on and off, and a wire that kind of connects and completes the path for the electricity to flow. That's what a circuit needs. Now, to break this down into smaller parts here, we have what are called conductors. And in a conductor, electrons are bound loosely to their atoms and allow electric charges to flow. So think about most of your metals. Wire inside of any kind of electrical appliance is metal. So these electrons can move easily from atom to atom. They're bound loosely. They're able to move from atom to atom. So that charge can flow, we would say, through that material. On the other side of that, we have insulators. In insulators, electrons are bound tightly to their atoms and do not allow electric charge to flow. So in this case, the atom doesn't want to give up that electron, so it holds on to it, and the charge can't flow or can't push through that material. So with insulators, kind of a side note, we'll have a high resistance or opposition to the movement of charge. So we call the idea of how fast, how easily, or how hard it is for electricity to flow. It's called the idea of resistance. It just kind of slows down or interferes electricity as it flows. And so simply put there, kind of the idea of the light bulb on the circuit would be a resistor. And so a resistor will slow down or resist the flow of charge. So that is going to be all for today, kind of a short unit, kind of bridging that gap between electricity and magnetism. There's a big point, I'm going to kind of go back to it here, is this one here that electric current produces a magnetic field. That's really the really big idea of the day. I thank you for watching, and we'll see you guys later on.